Well, hello there. Mr. Sutton here, bringing you the AB Calculus 3-1 Extra Practice number 4 solutions on the power rule. On this problem, since we have a variable to a constant, we can just use the power rule. So this is going to be 30t to the 29th. On this problem, to make our life a little bit easier, let's rewrite this first term as an exponent. So we can write this as -8 times x to the 3/4. And then using the power rule on each of these, we've got, let's see, 3/4 times 8, that's going to be -6. And we'll have x to the 3/4 minus 4/4, so that's going to be -1/4 power. Next, this is just going to be 9 because of the line rule, and we're done. On this calculator-based problem, we want to figure out, based off of this crazy-looking function here, which of the following statements is going to be true. So we're going to take a minute and enter this into the calculator, and then we'll go ahead and see what's what. Okay, here we go. So I've taken a minute or so to enter this whole thing in my y equals, my y1, and now I'm going to quit out of there. And I notice here that I'm comparing the same derivatives of numbers here. I'm taking f prime of -3.1, -1.5, 0.4. I'm just trying to figure out what order to put these in. So it's really just the same three numbers being used over and over again. So on my calculator, I'm going to take the derivative of those three numbers, write them down, and then I'll figure out what order to put these in. So going back to the calculator, now I'm going to just use my derivative function. I guess I could use the power rule on all this and then plug everything into that derivative to figure out what these are. But it's just going to be quicker for me and less chances for mistake if I just do math and then 8 pulls up my derivative function. And then we've got x, and then I'm just going to do alpha trace and put y1 in there so I don't have to rewrite that whole thing. So I'm basically just taking the derivative on my calculator, and now I can specify what x value I want to take the derivative at. So the first one I'm going to test out is -3.1. I'll just go in order from least to greatest. So -3.1, plugging that in, that comes out to about 14.974, give or take. Next, let me test out f prime of -1.5. Now, once I've done this once on the calculator, it's real easy to do it again. I'm just going to go up and yank my input from before, just press enter on that. And now I'm just going to go in and change the number I'm plugging in. This is going to now be -1.5. So that's about 4.922. And then one more time, we only have to look up f prime of 0.4 at this point. So going back, yanking that input one more time, let me delete that negative sign, and we're doing 0.4. Enter, comes out to about 4.387. All right, so putting these in order, it looks like f prime of 0.4 is the smallest one, and after that we've got f of -1.5, and then finally that's going to be less than f of -3.1. So taking a look at my answer choices then, the only one that even starts with 0.4 is choice D, and the rest of these are also in order. So choice D. For this problem, we're just asking for the derivative of this function. This is one of those where you have to do a double take, and yes, they really did ask this. Just have to use the power rule here. So this is going to be 5 times x to the 4th power, which is just going to be choice C. For this problem, the secret is rewriting this with a negative exponent before using the power rule. So this is x to the -7, and then taking that derivative, we've got -7 x to the -8, subtracting 1 from -7. So the only other piece of this is that the answer choices don't have negative exponents, so let's convert this back into fraction form. This will be -7 over x to the 8. Got to be careful there. Only the thing that the exponent's attached to goes to the other side of the fraction. So looking at my answer choices, that's going to be answer choice D. And you'll notice answer choice C is for those of you who thought the 7 should also move. And for those of you who can't subtract negative numbers together, they also had choices A and B. On this one, we're trying to find the derivative of the 4th root of x. So I'm going to start by converting this into a fractional exponent. This is really x to the 1/4 power. And then I'll just use the power rule to take that derivative. So this is going to be 1/4 x to the, let's see, 1/4 minus 1 is 1/4 minus 3/4. or minus 4/4 rather. So that's going to be negative 3/4 if I do that subtraction. And it looks like I do actually have the answer choice I'm looking for. No conversion to any other form needed. Choice C. For this problem, we're told that the g function is this polynomial here, and we want to know all values of x such that the derivative of this function equals 1/2. So to do this, first I have to figure out what the derivative of this thing looks like, and I can do that by using the power rule. So that's going to be 4x to the third, and this is g prime we're putting together now, minus, let's see, this will be 9x squared, and then this is just minus 1. And I need to figure out where this expression now takes on a value of 1/2. And if the answer choices weren't indication enough, we need to use the calculator for this. So in my y equals, I've entered my left side of the function is y1, the right side, just the constant function 1/2, is y2. I'm just going to graph these out and see where they intersect. But I do need to pick a window that'll be helpful to look at. So looking at my answer choices, it looks like the smallest one is a little bit more than negative 3. And the biggest answer choice, we're not going past, say, like 3.5. So let me put negative 3 to 3.5 in there. Just get me the smallest window possible. So negative 3, 3.5. And now I'll just do a zoom 0, zoom fit. And hopefully I'll get a good look at where these things intersect. All right, so there's my left side of my equation. And the right side of my equation, I can't even really see because it's so zoomed out here. But I can tell that I'm not crossing anywhere outside of, let's say, negative 2 and like positive 3. So let me move my window in a little bit closer. In fact, let me just change my window so my y values aren't so far apart. So let me just do like a y min of, let's say, like negative 5. And a y max, we'll go y max of 5. We don't really need more than that to see what's going on here, do we? Okay, so there's my function again, and there's my horizontal line through 1/2. Only one intersection, it's right there. Let me now do second trace, and then I'm going to pick option 5, intersect. Let me just move my little spider closer here. And where is he? There he is. Okay, so enter 1, 2, 3 times. And then we end up with about 2.3197 or 2.320, I guess, if you round it off to 3 decimals. So that's going to be answer choice C. On this no calculator problem, they want the derivative of this function here at 2. So let's first take f prime of x in general. Using our power rule, that's going to be 3x squared plus 6x, and then that negative 4 is gone because it's a constant. So we just have to plug in 2 for this. So plugging in 2, that's 3 times 2 squared plus 6 times 2. So that's going to be 12 plus another 12 is 24, giving us choice B. On this one, they just want us to find f prime of x, given this f function right here. This is just a straightforward power rule for the most part. So we have 24x to the 5th for that first term. And then this next one will be, let's see, negative 3 times 4, so negative 12x to the 3rd. After that, we've got 6x squared. And then finally, this one, you got to be careful. A lot of people are going to look at this and say, oh, it's 2e, like in this choice C answer choice. However, e squared is actually a constant. E is not a variable. E is a constant being raised to another constant. So a constant to another constant is just a constant, which means the derivative of e squared, since it's just a constant, is 0. So that leaves us then with just answer choice B. On this free response problem, the number of passengers who have boarded a ship is modeled by some differentiable function p, and t is the number of hours since boarding began. So we've got values of p of t in this table up here, and we have a few tasks on this problem. For one thing, we want to know the average rate at which passengers board the ship in passengers per hour over the interval from 1 to 8 hours. So we need AROC from 1 to 8 essentially. This is going to be p of 8 minus p of 1 all over 8 minus 1. So that's going to be 728 minus 35 over 8 minus 1. And that reduces to, let's see, this is going to be 693, I believe. Is that right? Yep, 693 over 7. We could just leave it unsimplified, but I think I can simplify this. This is almost 700. I mean, 700 over 7 would be 100. So 7 less than that over 7 is just going to be 99, and that's going to be 99 passengers per hour. For this part of the problem, we want to write p prime of 4.5 as the limit of a difference quotient, and then use the data in the table to approximate it. All right, so we're going to use Newton's form of the derivative for this one. So limit as h approaches 0, and then we have a big fraction. Now normally up here we would have f of x plus h minus f of x, but in this case we've got p instead of f. P is the function we're taking the derivative of. So we're going to have p of t plus h, and we're actually plugging 4.5 in for t. So we're going to have p of 4.5 plus h minus just p of 4.5. Again, p is getting plugged in for the 4.5 is plugged in for the variable, and we'll have all of that over h. So there's our difference quotient, and we don't actually have to do anything with this. We just have to estimate what it is using the table values. So to estimate an IROC, instantaneous rate of change, we're going to use an AROC. In terms of which average rate of change to use, we're going to use the one that has an interval that has 4.5 on it. There's a lot of intervals that do. The smallest one, and probably the most accurate therefore, is using the interval from 3 to 6. So we're going to do p of 6 minus p of 3 over 6 minus 3 in order to estimate this value. So that's going to be 600 minus 204 over 6 minus 3. Let's see here now. This is 396 over, let's see, over 3. Yep. And what can I reduce that to, if anything? Well, let me think. 300 divided by 3 would be 100. 96 divided by 3 would be 32. So this would be then 132. There it is. For this part of the question, they want to know if there's a time between 3 and 6 at which p of t equals 500. So if we're asking to prove that there's a specific output between two x values, typically that revolves around the intermediate value theorem, the IVT. To use that, we have to demonstrate that we have a continuous function on the interval in question, and that the y value we're looking for, the output value, is sandwiched between the starting and ending output values. So let's start with the continuity piece. Is this a continuous function? Well, they didn't say it was, but they did say it was a differentiable function. And for those of you who haven't reached differentiability yet, basically means you can take the derivative of something, and it requires among a few things that your function has to be continuous. So differentiability means continuity for this question anyway. Since we're differentiable, we're continuous on 3 to 6, so we have to establish that at the very beginning and have a good reason for it. Now that we've established that, we have to make sure that 500 is between p of 3 and p of 6, the starting y value and the ending y value. P of 3 is going to be 204. We have that in the table. P of 6 we already have is 600. Is 500 between these? It is. 204 less than 500 less than 600. So since we're going from 204 to 600 and we have a continuous function, that means we have to pass through 500 along the way. So that means then that the intermediate value theorem proves there's some time on this interval at which p of t equals 500. We don't know what time it is, but they didn't ask that. They just asked, was there any time on this interval where we meet this condition? And there definitely is. For this last part of the problem, we're told that the total number of gallons of water used by the passengers on the ship is modeled by a g function that equals 120t radical t, and between 0 and 8. So we want to know what g prime of 4 is. And they're telling us what it means in real life. This is the rate at which passengers are using water in gallons per hour at 4 hours. But we just need to find g prime of 4. I'm going to start to make my life a little bit easier by converting this into just one exponent. So this is really 120t times t to the 1/2. So adding the exponents, this is really 120t to the 3/2. And at this point, since this is just a variable to a constant, I can use my power rule. So 3/2 times 120, that's going to be, let's see here, 180. And this will be t to the 1/2 because we're doing 3/2 minus 1. Now I just have to plug in 4. Now when you do this, The 1/2 power we know is really the square root. So we're just doing 180 times the square root of 4, or 180 times 2, giving us a total of 360 gallons per hour.